Now this video I explained the calculation of the moment for the decompression points. We have calculated the load for the decompression point in the last videos, and we have explained these figures and those loads and these distances. Now we need to taking the moment about plastic centroid. As I explained, plastic centroid is located in the middle of the cross sections because we have symmetric cross sections. So if you take the ultimate moment, if you take the moment about this plastic centroid and anti-clockwise is positive, if you take the sum of the moment about this point, mu equal to 600, that C has the compression force in the steel is 600 kilonewton times by 1000 to convert into Newton, times by the distance from this force to the centroid will be taken as 300, take away 74. Now that 74 we take away, that is coming from the our question 74. So that distance you are measuring from this point to this point would be 300 take away 74 will give me this distance, which is 300 take away 74. So this is force times distance to the plastic centroid plus 5784 kilonewton. That 5784 is the force in the concrete, compression force in the concrete. Now we calculated the compression force in the concrete 5784 kilonewtons in the previous video, so that I use here, times by 1000 to convert into Newton, times by the distance from this force to the plastic centroid. Now we know that the stress block that we saw here was gamma KUD and KU was 1, so gamma D. So this force acting in the middle of this stress block, it means that this distance from the top of the top of the columns to this point will be gamma D over 2. Now we already know gamma 0.87 times 526 over 2, D is 526, that are shown here, that is 229. So over here that is 229 from this point to this point. Now if I want to know this distance, then 300 take away 229, that is the distance from this force, compression force in the concrete to the plastic centroid. Minus, these are all anti-clockwise moments, so these are taken positive, those two forces. This one will be clockwise, so therefore it's minus. That is the compression force in the steel, compression force in the tension steels. And the compression force in the tensile steels we calculated 88.9. I take 89 as a round number to work out easily, and 89 times 1000 to multiply by thousands to convert into the Newton, times this distance that we need to work it out. Now from this point to this point is 526, we see in this previous video. So 526 take away 300 will give me this distance, which is 526 300, that's this distance. So if you just work it out, this one you will get 526 150 000 Newton into millimeter. Divide by 1000, divide by 1000 two times to get in the kilonewton meter. So that is the moment for the decompression point. So in the first video for these examples, we look at this squash load, where we calculate 9360 kilonewton, where you have zero moment. So you have zero moment and you have 9360, that is the squash point. And now we have decompression point. Decompression point 526 kilonewton moment we just calculated, that I put it here, and 96483, that is the force that we calculated here. Now in the next video we will look at the next point for this axial load moment interaction diagram. Thank you.